For our final project in CS184, we implemented a fluid simulation with real-time changing density. To do this, we implemented Macklin and Muller's paper on position-based fluids. We modeled particles as open GL points in 3 dimensions and shaded them based on their heights. As you can see, the particles occupy a 3D space and are lighter on top and darker on the bottom as their heights get smaller. We began by modifying Project 4's cloth simulation code to remove all spring constraints. We added particles along a third axis and implemented gravity using discrete time updates based on Newton's second law. After that, we implemented density constraints to maintain constant density throughout the fluid. This required computing a position update, delta P, which was based on constraining the density local to a particle to remain equal to the particle's rest density. To solve this constraint for the position update, we calculated a Lagrangian multiplier lambda for each particle individually. We estimated the position update using these multipliers and using a small offset to maintain tensile instability. This S value accounts for negative pressures between particles that cause clumping when a particle does not have enough neighbors. We then implemented vorticity, which constrains particles to turbulent motion and adds back energy into the system, which is lost due to the position updates. We also implemented viscosity, which creates coherent motion by constraining particles which are close to each other to move together. Finally, we added a density slider to change the density of our fluid in real time. As the density decreases, it expands like a gas to fill the space, and as the density increases, the fluid takes up a smaller volume. We learned from this project that simulation parameters and kernel functions are difficult to debug. We spent quite a while messing with these ourselves. We also learned that fluid simulations are interesting and useful in film, video games, and science.